Alright, we're going to cover limiting reactants and what that means for a reaction. So the limiting reactant is the reactant that runs out first. So this will end up, this determines the amount of product that can be made. So since it runs out first, once it runs out, the reaction is going to stop. So it's going to actually determine how much product that can actually be made in your reaction. The excess reactant is just the other reactant. The reactants that you end up having leftovers of. Because the limiting reactant ran out, so you're going to have some kind of lingering other reactant that wasn't used up already. Okay, so we're going to do a recipe example on the bottom. So let's say you have this kind of really basic recipe for a turkey sandwich. For every 2 pieces of bread and 2 pieces of turkey, make 1 sandwich. So let's say in your kitchen you've got 3 pieces of bread and 4 pieces of turkey, and you want to figure out how many sandwiches you can make. Now obviously you can probably do this in your head, but we want to set up T-charts to kind of show you what it's going to look like for chemistry problems. So let's say you have your 3 pieces of bread and you want to know how many sandwiches that's going to make. In the recipe we see that for every 2 pieces of bread you can make 1 sandwich. So if you do 3 divided by 2, you get 1.5. So you can make 1.5 sandwiches with the bread you have in your kitchen right now. Let's see what happens with the turkey here. So for the turkey, you have 4 slices of turkey. We want to know how many sandwiches that's going to make. We see for every 2 slices of turkey, that can make you 1 sandwich. Okay, so 4 divided by 2, that's 2. Okay, so with the bread you can make 1.5 sandwiches. With the turkey that you have, you can make 2 sandwiches. So the limiting reactant is the reactant that causes the smaller amount of product being made, which in this case is the 1.5 sandwiches. So the bread caused that to happen. So the bread is your limiting reactant. It's the one that ran out first. You're only going to be able to make 1.5 sandwiches because the bread will run out and you can't make any more sandwiches without bread. The excess reactant would be the turkey, the one that gave you the ability to possibly make more product, but you won't. We're not going to do that part. Okay. Alright, so let's try a chemistry-based one. So here's our reaction, and it's saying, what if you had 5 moles of calcium and 2 moles of nitrogen? Which one is your limiting reactant? So you always need a T-chart for each given you have. So we're going to have a T-chart for the calcium one. So 5 moles of calcium. We want to know how much product we're going to make, the calcium nitride. Mole. Okay. So I see in my reaction I have, well, for every 3 moles of calcium, I get 1 mole of calcium nitride. Okay. So if you do 5 divided by 3, that gets you like 1.67. Okay, so you can make 1.67 moles of the calcium nitride product with the calcium. Let's see the other reactant, the nitrogen. So if you have 2 moles of nitrogen, how many moles of the same product, because we want to compare them, how many moles of the calcium nitride could you make with this reactant? So I see in the reaction, well, for every 1 mole of nitrogen, that makes 1 mole of calcium nitride. So 2 times 1 divided by 1, that's 2. So here I'm looking at my products. Which one's smaller? Well, 1.67 is smaller than 2, so I'm only going to be able to make this amount. Okay. Which means the calcium was my limiting reactant, and the nitrogen is my excess excess reactant. We kind of just rated X and S as a shorthand way of saying excess. Okay, so now it's asking, well, how many grams could you actually make the product? So what we do is we use the smaller mole number we got, and that's going to be the new given in this problem here. So 1.67 mole of calcium nitride. We want to know how many grams of calcium nitride we're going to make. So we're going to do the molar mass step here, that we know for every 1 mole of calcium nitride, we're going to figure out what's the grams of calcium nitride. Okay, so this is the molar mass step where we have to separate our elements. So we've got Ca, we've got N, I've got 3 calciums, and I've got 2 nitrogens. Now I'm going to look up the masses on the periodic table. So the mass of calcium, if you take a look, is 40, and nitrogen is 14. Okay, so we're going to put 40, oops, I already did that, and 14. 3 times 40 is 120, 2 times 14 is 28, so you add those together, you get 148. So that goes up here, 148. Alright, moles cancel out, so now I'm going to do my 1.67 times 148, and then we don't have to worry about that 1, so we get 247 about. We'll say 247.16. And this is grams calcium nitride. Okay, we'll do one more. Let's say I have 3.2 moles of calcium, 4.5 moles of nitrogen, which is a limiting reactant. So again, we need a T-chart for each. One-step T-chart. 3.2 mole of calcium, and we want to know the products, moles of calcium nitride. Just like the same ratio before, we have 3 moles of calcium for every 1 moles of calcium nitride. So the 3 moles of calcium on the bottom, 1 mole of calcium nitride is produced. Okay, so 3.2 divided by 3, and we get 1.067. Okay, now we're going to do the same thing but with the nitrogen. We're going to see how much moles of the product, calcium nitride, we can get. So 4.5, I'm writing the word mole in calcium. Make sure you use all your labels. And again, we're going to go to mole of calcium nitride. Same ratio we had in the previous one, but for every, this is nitrogen, whoops, nitrogen. For every 1 mole of nitrogen, we've got 1 mole of calcium nitride being produced. So mole nitrogen on top, we're going to put mole nitrogen on the bottom, and that's for every 1 mole of calcium nitride. Okay, so that's going to be 4.5 as the answer there. Okay, so the number that's smaller, 1.067 versus 4.5, it's the 1.067. So that means the calcium was our limiting reactant and ran out first. And the nitrogen is the excess one. We have leftovers of it. So we're going to use the smaller number, mole, that we got for the product as our starting point to figure out the grams of product that can be made. Because that's really what you would be concerned about in a lab setting. How many grams that you could make. Okay. We want to, again, go to grams of calcium nitride. So we're actually going to use the work from the previous problem. It's the same information. For every 1 mole of calcium nitride, again, the grams is going to be the same. 148 grams calcium nitride. So there's no need to do that calculation again because you get the same answer. Cross those out to show that they cancel. So 1.067 times 148. And we get 157.9 as our answer. Okay, there we go.